Okay, so last conceptual question of Chapter 3, Question 7, from the second edition of An Introduction to Statistical Learning. So here is the question, and roughly, we want to show that the R-squared statistic, given here, is equal to correlation squared. Okay, so if I were to take this expression and square it, all right, so I'm saying that R squared equals this expression squared. Okay, and so we want to show that, and we're going to show it in the case where x bar and y bar, or the mean of x and y, equals 0, just because it makes it simpler, makes the notation simpler. Some helpful formulas that will kind of get us going here is that RSS is the residual sum of squares, right? Is the sum of the observed values minus the predicted values squared, okay? And that the total sum of squares is the sum of the observed value minus the average value squared, okay? So I'm not going to go through the proof just kind of step by step in the video, so go to the Colab sheet and you can kind of work your way through this mess here, but I'll kind of show you how I did it. Well, actually a couple more useful formulas. So we are assuming that y hat equals beta x. Okay, that will be important. Notice that there's no intercept here. Why is there no intercept? The intercept represents the average, and we're assuming that the average y bar is 0 here. And then we also have the formula for the beta coefficient, which was given to us in an earlier question. Okay, so we want to show that R squared, okay, is equal to correlation squared. So if I take correlation, I square it, I get this term here. Okay, so I need to show again that this equals this. Okay, that my R squared ends up equaling all of this. Okay, again, you should go through this derivation. Here's the steps, and just kind of see what I did. I think it would be a little bit silly for me to walk through each and every step, but if you have any questions, then I suppose leave a comment, and especially if I made any error in this derivation, that would be good to point out as well. Okay, thanks.